Well, hi, hello, my dear students. Welcome to my video lecture class. Right up to now, I uploaded video lectures on the topic Newton's laws of motion. Today, I would like to discuss applications of law of conservation of linear momentum. In the last lecture, I discussed application number 1 based upon law of conservation of linear momentum. In this lecture, I am going to discuss application number 2. Application number 2. A bullet is fired from gun moves with velocity, moves with speed v, moves with the speed v, and embedded or penetrated into wooden block, penetrated into a wooden block of mass capital M, and penetrated into of mass capital M at rest. Then it moves on smooth surface, smooth horizontal surface. Find common velocity. Find their common velocity. So observe carefully here. So let us consider. So this is considered as a gun. Okay. This is considered as a gun. Okay, bullet is like this. So this is a bullet. So these are bullet. So this is considered as a gun. So bullet of a mass small m. It is moves with the speed v and hits the block. It hits the block of mass capital M. Hits the block of mass capital M. This is a block. This block of mass capital M. This bullet hits this block and embedded into this block. These bullets are embedded into this block, and this block is moves. This block moves with the speed v. Block moves on horizontal surface with the speed v. Okay, so moves on horizontal surface with the speed v. So here bullet is embedded into the block. Okay, so according to law of conservation of momentum, so what we apply here, momentum of bullet before hit the block before hit the block is equal to momentum of block after penetrating of bullet. Okay, so momentum of bullet before hit the block, momentum of block after penetrating bullet. Okay, so this is we apply according to law of conservation of momentum. So momentum of bullet before hit the block, that is small m into v. Momentum of the block after penetrating bullet mass and this block mass. That is equal to capital M plus small m. Into common velocity is v. So this is very important. So finally we got here small m into v is equal to capital M plus m into v. So before hit the block, momentum of bullet is small m into v. After penetrating bullet into the block, the momentum is equal to capital M plus small m into capital V. So now common velocity, So here their common velocity. So common velocity common velocity of block and bullet moves on horizontal surface is a V, capital V. From this, what we got here, small m into V by capital M plus small m. Small m into V by capital M plus small m. Okay, capital M plus small m. Here. Here small m is equal to mass of bullet. Small v is equal to velocity of bullet. Capital M is equal to mass of wooden block. Capital V is equal to common velocity of bullet and block after penetrate of bullet into the block. After penetrating of bullet into the block. So this m is equal to mass of bullet, v is equal to velocity of bullet, capital M is equal to mass of wooden block, capital V is equal to common velocity of bullet and block after penetrating of bullet into the block. So this application also solved based upon law of conservation of momentum only. Momentum of block, momentum before hitting the block, momentum of bullet before hitting the block is equal to momentum after penetrating a bullet into the block. So conservation means, so whatever the momentum before is equal to momentum after. Conservation, constant. Momentum before hitting is equal to momentum after hitting. That is called conservation here. Okay. So next application number 3. Application number 3. So this is very important application. Application number 3. Application number 3. Application number 3. Explosion of bomb. Explosion of bomb or shell into 2 pieces. Explosion of bomb or shell into 2 pieces. So let us consider of a bomb. This is a bomb. It is explodes into 2 pieces. This is 1 piece. This is another piece. Explodes into 2 pieces. So one is moves in this direction, another one is moves in this direction. Okay. So let us consider a bomb. Let us consider a bomb. Let us consider a bomb. Consider a bomb which is application number 3. This is application number 3. So let us consider a bomb which is explodes into 2 parts, which is explodes into 2 parts. This is part 1 and part 2. So part 1 having mass I will consider as small m. So definitely this is a bomb of a mass capital M. It is explodes into 2 parts. One part having mass small m and another part having mass capital M minus small m. Definitely capital M minus small m. Okay. So one part having mass, part 1 having mass. This is part 1. This is part 2. So one part having mass small m, second part having mass capital M minus small m, which is explodes into 2 parts. Bomb of mass m. Bomb of mass m, which is explodes into 2 parts of mass small m and capital M minus m respectively. After explosion 2 pieces moves in opposite direction. 2 pieces moves in opposite direction. 2 pieces moves in opposite direction. Okay. So this is very important. 2 pieces are moves in opposite direction. Opposite direction with a speed small v and capital V respectively. Okay, so this is a small part, large part. Okay, so what will happen? According to law of conservation of momentum, according to law of conservation of momentum topic. Okay, momentum of small part is equal to momentum of larger part. So that means here small m into v is equal to capital M minus small m into capital M minus small m into v. V means here capital V. So from this, so this is so thus we got here. Okay, so explosion of bomb into two pieces, then momentum of smaller part is equal to momentum of larger part according to law of conservation of momentum. So now define, we are going to be defined. So small m and v, right? What is the values here? Here are the main values. Here are the main values. Here small m is equal to mass of small part, small piece, capital M minus small m, mass of larger piece of bomb, small v, velocity of small piece of bomb, capital V, velocity of larger piece of bomb, velocity of larger piece of bomb, capital M is equal to mass of bomb or shell. So this is okay. Momentum of small part is equal to momentum of larger part. This is very important while solving problems or numericals. In based upon this concept is very useful for solving numericals. So please focus carefully. So this is about today lecture. So again I'll come back with new concepts and newer problems. So please watch my lectures. While watching lectures, if you will get any doubt, please mention in comment box. Thank you for encouraging me. Thank you for supporting me. Again I'll come back with new concepts. Thank you so much.